Thanks, it's a pleasure to be here, and thanks, Michael. He was a star even when he was a freshman graduate student at MIT, and I do remember that talk, which was, it was a joy to give that one. It was, HCI was actually hot at MIT then, which wasn't true the first couple times I gave talks at MIT, so it came a long way there, and I think Michael's part of the reason why. And if you can't hear me, please let me know. Am I speaking loudly enough? Yes, okay, great. So, teaching is coaching and learning at scale. I'm very passionate about this topic. I think most of us who are professors who teach, spend a lot of our time teaching, think a lot about how we teach. And so, thank you so much. So one thing I want to do is I want to put my money where my mouth is and make this into a lecture, make this into one of my class sessions. So I'm going to start with a question. Okay, what's the best way to present this data? Audience participation. Here's some data. I'm not even saying what it's about. What's the best way to present it? How should it be presented? All right, think to yourself the answer. And it's a little bit hard to answer that in a setting like this. So I'm going to reword the question a little bit, make it a little bit easier to answer. Which of the following visualizations is the most effective for presenting this data? Is it 1, this one, or 2, this one? How many people think number 1 is the best? How many people think number 2 is the best? Okay, everybody's voting for number 2 pretty much. And for those of you who study visualization, there's a lot of reasons. There's visual principles. Area isn't best represented this way. It's misleading. Color is not used in a way that's helpful to allow you to make the comparisons. Length is a better way to show quantitative differences, and so on and so forth. This is a very easy one, all right, if we know anything about visual principles. Let's try another one. What's the best way to describe or visualize this data? Okay, and that's only a very small fraction of it. It's going to be a little harder to answer that one. Don't shout out your answer yet. Let me reword the question again. Which of these visualizations is the most effective for this data? Okay, that, or that? Of course, you can't even really see the numbers. This is Jeopardy. This is data from the show Jeopardy. And it's about which questions, which categories of questions are used, and how much money people have made from the different categories, and so on. Does anyone feel that they know definitively which one might be best, most effective? Well, for what, I actually haven't said what for, and that's another issue. But imagine you're a professor who needs to give feedback to students on this very high-dimensional problem, visualizing data at this high dimension. If you're like me, it's not actually super straightforward to do. You might have some views, but you might not be absolutely certain you're going to give the right feedback about these. Maybe you will know that that's not so great because of various reasons we can talk about, which I don't have time to talk about. But these two, they have pros and cons. It's kind of difficult. So keep that in mind as I go on. So what I want to talk about is sort of two different topics that I feel are related. One is learning at scale, what we see with MOOCs and so on, people putting courses online and having many people learn together, or not together, but learning at once. And this idea I'm calling teaching as coaching, which is how I now think about teaching, which is rather than we give students material, and then they're tested, and they got it right or not, and they better study and get it right. I'm thinking more like the sports metaphor, where a coach has practice, and they're alongside the athlete, and they have them practice, and they fail soft and safe, and they repeat, and so on. And maybe the exam is the big game or something like that, but the coach is on your side, and you just repeat and fail fast. It's more like that, and that's how I'm trying to teach my classes now, which is sort of a different talk. But what I am kind of thinking about is these two are kind of related. I'm thinking about the two, they're interwoven. And we can think about two different things, at least I am. One is pedagogy that interlinks these two, and in particular, mastery learning and structured peer learning. I'll talk about both of these. And the other is tools, so technical tools that we can develop that are motivated by these pedagogy, and pedagogy is the science of teaching. And in particular, automated feedback, peer feedback, and online discussions. And so let me talk about these briefly. So mastery learning, I got a little bike here because Salman Khan talks about the Swiss cheese model of learning, where you kind of fall through the holes, which is when you're in traditional teaching environments, you study a math topic, you maybe get a C on the test and you move on. But a C on a test means you didn't actually learn it properly, and yet you're supposed to go on to something that builds on what you had before. So it's kind of like learning to ride a bike where you didn't master the balance part, but now you're going on to pedaling. It just doesn't work. So a lot of the thinking now is that mastery learning requires practice, and if you want to do practice, you need feedback to know if you got the questions right or not, at least for math. And there's a lot of really interesting automation work going on with automated feedback, automated tools for feedback, say with math problems. I will not be talking about that today, but that's kind of one way to go, is with fully automated feedback tools and modeling online what people are doing and personalizing, say, the feedback automatically. So that's a really exciting area, learning at scale, that I won't be talking about. But there's another issue, which is for more qualitative work that students are doing. And so another trend is to have peer feedback. When you have a lot of students, you can't have one instructor or a few instructors give them all feedback. And furthermore, there's a lot of benefits to peers giving feedback to each other, which we'll talk about. And this is especially important for qualitative work, like writing essays, or design, like HCI, or information visualization, where there's judgment calls, potentially. So peer assessment in design courses, the state of the art, is work that's been done here at Stanford, well, sort of Stanford and San Diego and CMU, and depends on how you count, but kind of all around, about Kulkarni et al. The key ideas here, so they've been looking at HCI courses in particular, although it's been used in other courses too. And the trick is to have students have a rubric, which is basically just a table saying, here is what you need to look at when you are assessing, say, this design. You train the students on other examples of that rubric. You say, look at how, here's a design, look at how the instructors graded this design in the past or gave feedback on it in the past. Now you give feedback on a design, and then, oh, well, you were off. You didn't grade it sort of the same way as previous instructors said you should. So why don't you adjust? And that's working pretty well. It's getting students, and this is an example rubric where you have like a category. Then here are like the different scores you can give it: unsatisfactory, bare minimum, satisfactory, above, and beyond. And you sort of train the students into how to do this rubric for each assignment, and then you have some peer assessment. So this is working pretty well, but there are a bunch of issues, and there's a lot of really interesting research going on around this. So Kulkarni et al. Noticed various things, like students sometimes feel like they put in more effort than the other students. This is a common thing that we see with things generally in classrooms. There's issues with transparency. So Renee, who's sitting here, has a new paper about that, if they're not sure how the grading is being done, then they have some questions. But if you show them too much about it, we've all seen this. If professors have tried to show how they graded exams to students, because the students think the grading wasn't fair, and then the students are even more unhappy. This is sort of a well-known result. There's differences in how difficult a TA is on the grading, and then the students get upset. There's been some work on grading the grader, like let's grade the students to see how good of graders they are. There's issues, though, with negative reviews. They can get low ratings, and people generally these days react negatively to negative feedback. So there's a lot of issues that come with this peer assessment. So we did a little work recently to think about how can we improve peer assessment, say, in the design space. Or that's how the result came out anyhow. And so the idea actually is to trade off two different approaches. And I'm saying it's kind of like ensemble learning in machine learning. So let me talk about that now. So first I have to give a quick review of heuristic evaluation. And since this is a PCD seminar, I think most of you probably know what it is, but maybe not all of you. This is a very standard approach to assessing designs, user interfaces. Basically, you have a set of experts with a set of guidelines, go through the guidelines, review a design, and say how many errors there are, how many problems there are with the design, or how good the design is. And then you aggregate their results. And this is very widely used in practice in user interface design, developed by Nielsen and Molick in 1990. And so here are some heuristic guidelines for visualization that from a report by Stephen Few, like do not use chart junk, do not use color, shape, and so on arbitrarily, do use length and position properly to show quantitative variable values, do not deceive, et cetera, et cetera. And so if we look at our beautiful graph from before, we can look at it and say, for example, which guidelines apply or which ones are violated by this chart. And for example, do not use color arbitrarily, although I guess it's the colors of the flags. Use length and position for quantity, that is violated, and highlight salient information that is violated here, etc. All right, so what's the standard alternative to heuristic evaluation that is used in the literature? There's other things, but kind of the main alternative is usability studies. Have people actually try to or use the design. And so you can have a whole big system built and do a study on it. And one of my favorites for search visualizations or search interfaces is this very old one by Ryder et al., where they compared bars, tile bars, and a scatter plot to kind of just a sort of a list view, and found that the list view is basically the best, except for tile bars is second best. So that's one reason I like to review the study, because tile bars is my thing. But the effectiveness, the table is best. It's really hard to make visualizations work for text and search, which is why we don't have them. But very careful study done by the people who didn't develop the design, which is really the best way to do these things. But there's also been studies on visualizations themselves. And so there was this paper in Tokai 2014 by Yang et al., where they were like, let's just do pairwise comparisons or studies of like bar charts and line charts and stacked bar charts. So all they did was a whole bunch of comparisons of how do you group these pairs together. And it was this enormous amount of work because they wanted to see which ones to use for which kinds of questions and what kind of questions did people ask with these different types. And it turned out like they asked about extrema and they did comparisons for correlations. But it was a huge amount of work just to look at these pairs. And let's think back at the example I showed you with the Jeopardy data. Those were not just like a couple of lines. Those were very complicated designs. So they did get some scores for a few pairs for a few question types, but we don't have user-tested data for really complicated combinations of designs. So it's going to be really hard for, say, a professor who's trying to give feedback to students to sort of definitively state which ones are correct or right and so on. So there's also been work on using Crowdsourcers to do usability tests. So we have this nice paper, Do Mechanical Turk Stream of Square Pie Charts by Coursera, where they did this. So there's been work also by here and his co-author on replicating some perception studies using Crowdsourcers. And it turns out these squarified charts are better than pie charts and donut charts for looking at proportions. So that's how you can do sort of these usability studies. All right, so I thought, well, okay, people are using Crowdsourcers to do these little usability tests. Why don't I use this in my class? I could make use of the crowd to help assess my students' work. And I was inspired by this work by Dow et al., also sort of done here and elsewhere. So the idea was students should radically iterate on their designs. They should work in teams. This is from the Dow et al. Work. And then you can assess the results. What they did was they had people make UIs and post the results on Google AdWords. And that was very clever. I'm like, wow, an objective assessment. That's great. The only problem was it was AdWords. It's like, click on an ad. And to me, that's not really a usability goal so much. That's like a selling goal. So it's not perfect. It's not exactly what I want. So what I did the last 2 years was I had neutral parties, the Crowdsourcers, answer questions about the underlying data in the visualization. So I got a data set, and I had the students make a visualization about the data set. So I gave them a data set, I made up a set of questions, I put their designs on the crowdsourcing platform, and we saw how many questions the people got right. And the theory being, if they got more questions right, it was a better design. And I also had the students first design individually, and then I paired them up in teams and had them iterate on their designs and have a team submission. Okay, so we got pretty consistent results. It was great. It was a great exercise. But then I wanted to think, well, why don't I do this with peers instead of crowd workers? The students should answer each other's questions, although you can't have, the problem with that is once you've answered questions about a data set, you know the answers, so you can't repeat. So you have to have more students. And then I also was like, well, how does this compare to heuristic evaluation, which is sort of a standard technique? It's a standard technique in user interface design. It turns out it's not that standard in InfoVis, at least in my experience in InfoVis classes. And you think about that. I don't think it's really used that much in InfoVis. And I have some sites to back that up. So my question was, well, which is more accurate, or which is more helpful? I was kind of thinking the question answering might be. So I did a study. This summer, we had 47 undergraduate HCI students. We had have a lecture and some exercises with InfoVis, and within participants' design, where there were two conditions, HE, heuristic evaluation, or question answering, with 6 different data sets, 3 designs each, and I attempted to have them be of low, medium, and high quality. I made the designs, and that was the hope. So the setup would be, there was a question, there was a data set with a question, there were 3 designs, and then the students assessed them. They either answered questions about the designs, or they did a heuristic evaluation on the designs, and we did this for multiple data sets. So in the heuristic evaluation condition, I actually had them do only positive heuristics to keep the scale. Yes?
Sorry, was this cross, like in some sense, or was I in heuristic in one data set and then over using back in another?
You would only do heuristic in one data set and question in another, so that you couldn't, yeah, right, yes.
And then all these are only talking about static visualizations, not interactive ones.
Yes.
Okay.
Keeping it simple, yes.
Why do you expect heuristic evaluation to be better than answering questions about?
No, I expected questions to be better. Did I say it the other way?
Well, maybe.
I was wrong.
What was your hypothesis?
I wasn't right, it turns out. So does it matter because I was wrong in the end? I had a bias. I thought that this objective answering the questions would reveal the true underlying merit. Because I had never done heuristic evaluation in InfoVis, which I'm now going to do because of the results of my study.
But I would think the same thing as you.
Right?
And so, there's this question about why the task is to extract the data from the visualization.
Yeah.
Right? That's what you want the viewers to be able to do.
Yeah.
So why should heuristic
evaluation?
Well,
let me finish the. Because I'll have some more reflection on that, okay? Let me get a few more slides and then let's talk about that. Did you want to? Let's do a couple more slides and then let's talk about it, okay? So the heuristics, I had them do 3. By the way, I should say these are undergraduates brand new to HCI in a 6-week summer school course, and then we had the 1 segment on InfoVis that I taught. So I had them only do positive heuristics so they wouldn't get confused between positive and negative. And so they would rate 1 to 5. The visualization is visually salient. The components are used appropriately, and it has the visualization successfully presents multiple relevant facts into a single visual pattern. And then on the question side, each data set had a different set of 3 questions depending on the underlying data. So, for example, for the Jeopardy data, you would have which year on average was the most lucrative for players in terms of earnings. Based on these numbers, which category would be the strategically best to select as a contestant in the game, and so on. And there were 3 choices, and only 1 was correct. So the new idea is to compare assessments on a measure scale. So this is the new thing that we did. So the procedure is the following. We create measures for the HE and for the heuristic evaluation and the question answering approach. we compute the correlation between the two, and we assess the reliability. So this is the new thing. So that for the HE, the composite rating per participant was to average the 3 HE scores, and the QA, the composite rating, was the number correct averaged. So that's the new thing. And then when we plot these, we get a fairly high correlation, especially when we removed one outlier, which you can see here kind of pale. So what I'm showing here are for the 6 data sets, they each have 3 visualizations, so there's 16 points with the average scores, with the average question score on one axis and the average heuristic evaluation score on the other axis. So for example, if participants tended to agree that the design, I'm blocking here, that the design was strong on the HE condition, then they also tended to answer correctly in the QA condition and vice versa. So we found a strong correlation, well, a moderately strong correlation between the two. So that was really interesting. However, you will see that the HE was more reliable, somewhat more reliable than the QA, and I'll talk about that a little bit more. So without the outlier removed, it was a less strong correlation. It was 0.38 in this case. So now the really interesting thing is if you have outliers, what does that mean? So we do have this outlier. This is in the Jeopardy case. So these are the 3 Jeopardy visualizations, and here are where they fall in the chart. So what's really interesting here is you can look at where do they fall with the question score and where do they fall with the heuristic evaluation score. And then you can look at, and this is the one where we had the big outlier, and this was 52. And that's one reason I've been using this example. It's a case where people didn't give it as high of a HE, they gave it, actually, let's see, yeah, not as high of an HE score, but it did well on the questions. So this would be a case where, as an instructor, you might want to take a closer look at it, where maybe your intuitions or your standard way of assessing something you need to take another look at it. And so that's why this is this kind of an interesting, I think, way to think about doing assessments as an instructor, is that you're having these 2 ways of measuring that are kind of correlated most of the time, but when they're not, maybe it's worth taking another look. Furthermore, in other cases where, in this case, this is data about autos and mileage, they're all pretty close. So they're pretty close on the question score. One of them, though, has a higher heuristic evaluation score, number 21, which is the one on the top. So they're answering questions equally well. Like, I actually thought this one wouldn't do very well because to me it has some poor design components, but it kind of maybe got lucky on the questions. So that's a case where maybe you were going to want to add more questions. Maybe we don't have enough questions to tease that apart. So I'm going to talk about that more in a minute. And here's another example. These are, this is dog breeds data set. And you can see here where one of them is clearly doing worse than the others. This is what I expected. The stacked bar chart, number 41, is doing poorly on both dimensions. But the other 2 are doing pretty much the same on the question score. One is rated more highly on the heuristic score. So again, this gives you a lot to think about. So how might you use this tool? Yes?
So it tends to be when there's a difference that they're rated lower on the heuristics, like they did poorly in the heuristic evaluation. And
when there's a difference?
Well, like this outlier and also the second one here, 42, I'm wondering if it's, heuristic evaluation, one of the criticisms of it is finding false positives. So, like, you're finding problems that don't exist when real people use the interface. So is that what those are examples of in this case? Or do you also find the opposite, that you get a high average question score? No, you would have to get a low average question score.
I think you could find the opposite. We didn't find the opposite in this data set, but I think you could. I mean, that's why I'm actually going to run it again this semester in my class. So that's the thing is, this is just one run of this. So I think we need a lot more tries with it to see what happens. And let me talk about the reliability assessment. So we have two different measures for each visualization, but we don't have any ground truth. In the end, with this sort of thing, there's no ground truth. Is this how many questions you get right the ground truth, or is a heuristic evaluation or some other judgment thing the ground truth? That's kind of, to come to your question, I don't know. I mean, the arguments from the 90s about this were about that as well, right? There's not a true ranking for these things, no matter what we think, right?
In Nielsen's original stuff, they say the ground truth is doing usability testing, because they say it's real people doing some real tasks, and isn't your question
And they call this
answering
discount usability.
Yeah, but
closer to that?
yeah, I know they said, some people said that, but people didn't necessarily agree with that. And also, when you look at the literature on information visualization tasks, there's a lot of classifications. So just the use in this manner is like one of 12 classifications. So it's definitely not, so that was my starting point. You see that when Manish said, why was that my assumption? I started with this utilitarian assumption, but it's not necessarily the case, because I might not have asked the right questions, for one thing. So, and actually the HE was surprisingly effective at getting at what the question answers found. That's what surprised me so much. It was really quite, these really fast HEs that these students did was really quite well aligned with what the questioners got. So that's what impressed me so much. Sure. No, I've been looking forward to hearing your thoughts on this.
When I think of HE versus usability testing, although originally Nielsen and others tried to say, hey, here's a discount way of doing this, I often teach it as these are different things that will find you different problems, and you want to be iterating between them, and this reduces your cost. But you'll find different things that HE will find things that you would never find in a usability test, and vice versa.
Yeah.
And therefore, like, just that I would compare them.
Yeah, and I have the
Seems
three
wrong.
slides on that debate through the 90s.
Right.
Well, actually, I'm going to unhide my two hidden slides here because I had a feeling, but I didn't want to go there if it didn't come up. Okay, I'm going to jump to these right now and then back up to the reliability thing. So yes, that was the debate all through the 90s. And then, so the people that have revisited it, this Hollingston and Novick from this usability inspection methods after 15 years of research and practice. Okay, so they surveyed it, said people are still using these things. It remains an open issue as to why usability professionals in practice rely on single perspective methods, typically involving users or experts, but not both. And then they listed 5 research problems that should be addressed. A further research question involves possible means of combining multiple dimensions of perspectives in a unified usability inspection method. So they said it should be combined, and Zhu, measuring effective data visualizations, said, much foundational research needs to be done to improve the measures of effectiveness of information visualization, including closely correlate systematic heuristic evaluation with user studies. So I found this after we did the work, and I was reviewing literature. 2 different authors called for doing what we did. So I'd say that some thinkers are saying this is probably a good idea. That these people reviewing that back and forth of it's one or the other are saying we ought to combine them. So it is a new way of thinking about it. And I have to tell you, I've been wrapping my head around it too and saying, is it different than doing them separately? Does it have benefits? I welcome you cogitating on it and seeing if you think it gives insight or not. We have this reliability assessment. Sorry, I'm going backwards, it looks like. So we can't say which measure is more accurate, but we can say which is more reliable. In other words, which procedure generates a ranking that's more consistent from one set of data to another. And so this is based in part on the standard deviation of the mean scores for each design. When we did this, we found that the HE for our data was more reliable than the question answering. There could be a lot of reasons for that, but it does suggest that if we add more questions, that might improve it. And one reason is that the scores were binary. Either you got it right or wrong for the question answering, and the HE is graded. But there is a lot of research showing the importance of finding the right tasks. This is true for InfoVis. It's true for information retrieval. So I just think I really felt like I was just picking some questions, and it was, I did it for a study. It wasn't systematic. It was based on this Yang et al. Stuff. But, what if I'd had 2 more questions? So I think that is, but it's much more variable, as well as what data did I put in the thing. There's a lot of variables. So I think it needs more study too. But I think it's a new take on the HE versus UT debate of the 90s, which has kind of stalled since 2007. But the idea is, instead of finding discrete usability problems, describing designs in terms of continuous quality scales, which allows for spotting of outliers, which might be special. And this problem we have with grading at scale, where people feel if they do something special, it gets ignored, it gets punished, right? So we want to avoid that problem. It might address student skepticism about either method, about the utilitarianness of one method or about the arbitrariness of the other method. And it might be more accurate for ranking designs. Because imagine if we have a huge database of designs that have now been assessed, and you want to add a new one in. We can imagine this big scale we've developed, where there's 2 different measures pulling off each other, kind of like ensemble learning and machine learning. Now we know ensemble learning and machine learning works best if the ratings come from different distributions or different underlying sources. And so that's kind of where I think we have some interesting, it's an interesting idea, which we don't typically have in HCI. Question or comment? So that's what I think is kind of neat here. So it's a new take on peer assessment, I think, for HCI. And so we have 2 different kinds of evidence that we have some idea correlate, but that come from different places. So this study, the design was by the instructor, the question was by the instructor, and the viz was by the instructor, and the HE and the QA was by the students, like this. This spring, the visualizations are going to be done by the students, as well as the HE and the QA. So now the students will be making the visualizations. And my hope is, this summer, to take it online and have the questions made by the students, and maybe the data sets chosen by the students, although that might probably be delayed a bit. But eventually, everything done by students, and make a huge data bank of ranked assessed visualizations, high-dimensional ones, so that we can really learn what works and what doesn't about complicated static visualizations to start with. And so that we can actually discover new design guidelines. I found, even with the first study I did with just the crowd workers, that my students came up with what I felt were new design guidelines that I would have been a little less confident about had they not scored so well, that I hadn't thought of for doing what they did. And so I think we'll find new viz design guidelines from this approach. The advantage of this over what's been done before is because I'm varying just the data sets and the questions, but the method stays the same. We'll be able to get a lot of mileage because you're still looking for extrema, you're still looking for correlations or patterns, whereas when you do a general HCI class, the goals are very different in what the user interfaces are. So there's a more systematicity. So I think we have more of a chance to get general principles about InfoVis out of this potentially. Now it might be that the scores are not valid enough, that there's, because of what the students are doing, that we won't be able to trust the results. So we might have to put more checks and balances in, or it might just not be valid. But it might lead to a better understanding of InfoVis. And it's sort of a cleaner model than just general HCI, I think. So let's revisit what you were asking at the beginning. I want to come back to the questions you were holding.
Assesses it, but one thing, this depends a lot on the questions that you ask, and a lot could be backed up in that, and so I'd like to see those at some point.
Yeah, so I think that actually that's why doing it multiple times with different questions will help sort it out. if you have a lot of students, you could have a lot of different questions.
Well, you can ask questions that are very tied to the visualizations.
Right.
So if you say, give me the value of this particular bar, and that value is in a label on that bar, the visualization has made it very easy to answer that.
So what I did with my students is I didn't tell them the questions in advance. Yeah, so that makes it harder for them to.
Still, the questions can be tied to specific forms of visualization.
So you can make rules about what the valid questions are, so they have to, have constraints on where they are in the Bloom taxonomy and things like that too. And yeah, so I think that's a very valid point. Yes.
Coming back to a point you were making earlier that this was about assessment in these classes, you made, I think, correctly a point that that unless you have a simple and transparent grading scheme, like the more complex you get, the less trust that students have in this.
Right.
So I'm wondering if this sort of ensemble or sort of PCA-ish assessment mechanism produces higher or lower trust in the assessments that are returned.
Oh, I think it's a very, very simple. It'll be very, very simple. It would just be the average score that you got right on, unless you made it more complicated. It's really just the average scores people got right on a visualization and the average HE. That's what we're doing right now.
So now I'm a student and I get that feedback. Am I more willing to accept the feedback if it's the expert HE, this is how people empirically did on your visualization, or this sort of mixed assessment that somehow is a weighted combination of them? And I'm wondering where does the simple one actually get absorbed more readily?
Well, I'll tell you that when we did this in my class, the students. So one of the students said, okay, so those of us whose scores aren't very high with just the question answering, so you're going to give us feedback, aren't you, on how to improve it? So I think that's kind of, and I'm like, yes, I am. In that case, they wanted to hear how to improve their design. So what I'm thinking here is that students, if you have like a plot showing where theirs fell with respect to others, if we had a way to show the differences between their designs and others that did better and worse on the different questions.
Right, so you show the JNT.
You would show that, yes, I don't know if it would be just noticeable difference or a more explanatory difference of, how these different visualizations handle the different parts of the data set. I think it could be quite explanatory. So I think you could get beyond that. It would actually be almost a literal description of how they were different.
One opportunity I see here, and you're probably, I'm preaching to the choir here, is that you've, in this sort of coaching metaphor you're pitching, you've made the instructor, extrinsic to the grading process in some way, which means that by complaining to you, I can have no effect on how well people could use the visualization, right? So if normally someone comes to me and they're like, look, my visualization's great, isn't it? And I say, actually, no, it's not very, no, it is, right? This becomes a debate about my opinion versus theirs. And what you've done is you've essentially sucked it out into some external thing that's like, well, people didn't do very well with it. I can help coach you, but I can't change the fact that this happened. It might have some impact on the relationship you have with the student as you're doing this assessment.
Well, I think you wouldn't do this for all assessments either. So that's, you have multiple ways of doing things in the class. But actually, I also think this would be a really great way to assess the heuristics as well, or the guideline assessments too. Because these are they're more like the rubrics that you see in the standard peer assessment. And you could see which ones lead to helpful feedback and which ones don't as well, to help explain to students why their designs did well and didn't do well as well. Because those are in language, And so you'll have both this thing that shows, as we know with usability tests, when people don't get things, when people are lost in design, that's a very effective way to communicate to people why the design is poor. And the same thing would happen, someone couldn't answer a question about your design. That's very, very powerful. Then people want to understand why not. And the heuristics the guidelines could help explain why not, as well as the diffs. So the students who didn't do well on this thing, they couldn't really question it because people couldn't answer the question. That, it's very compelling, but then they want the explanation for why. So, yeah. Yes.
Who do you think would learn more if you're to do this twice? Someone who doesn't do well the first time, or someone who does do well the first time, if they had to repeat kind of the exercise again?
I don't know. But I do think if students do find it compelling that they could repeat it multiple times and do variations on their design. I don't know. I don't know. Who do you think would do better? Who do you think would help most?
I think probably the negative feedback folks would be more inclined to really dig in and see what they did wrong.
I think as long as they find the feedback helpful,
Yeah.
Yeah. And what I do in my class, by the way, is I have people read the Dow et al. Paper, and then I ask them if they'd like to do that. I get buy-in. There's a whole side thing about the pedagogy. Oh my gosh. Oh boy. Shall I move on, or just stay with this and not do the other stuff?
The power is yours.
Question back there.
Well, just an idea. It seems like if I wanted to solve the question, part of the issue here is that people are trying to be graded on somewhat subjective task. And so if I wanted to discover objective ways to optimize data visualization and I wanted to make a class fair to students, the way I would experiment teaching it is to actually use physiological biomarkers of a person's response to a data visualization. So a great example is Flywheel or Equinox. They have spin classes now where data visualization is key to driving improvement in fitness. And so then you have a very specific physiological marker. As a function of time, you have how many watts is someone producing in response to a data visualization. And then the students have a very objective measure. And then you can even customize the visualization by conditioning on information about the participants. So someone in a retirement community might actually have vision impairment in a way that a teenager might not. And so then you can actually discover optimized parameters based on very measurable quantities. And you could do that with eye tracking or any of those other sorts of things.
Wow. So do you want to measure for the emotional response? Do you want to measure for if people feel that they're gaining learning?
It's just like you have.
You definitely want people to opt into that, of course.
What's that?
You definitely want people to opt into that sort of thing. But
Well, the course would be like, how do you optimize?
Design for each other. Yeah.
You can optimize these measurable parameters, and you create data visualizations that do that.
Well, it's a great riff on the idea. Awesome. Okay. Oh, another question? Sure.
So you mentioned potentially having students come up with the questions in an online course for the QA part. Could you just talk a little bit about how you think about evaluating the quality of those questions at scale?
So we definitely, that's something I want to touch on too, is the whole crowdsourcing thing. So we definitely want to use some of the techniques that are used for some of the crowdsourcing work where you have to have a loop to see how well that's working. I mean, that could be a whole assignment in itself. So there's a big debate right now, not a big debate, but there's a debate in InfoVis about what makes a good visualization. So a lot of people are talking about visualization for insight and how do you measure that. So what we're doing here is just this very narrow, can you extract a piece of information, and that's seen as super narrow. I do this in a very early exercise in my class. We have this whole EDA, exploratory data analysis component that's much richer and much more difficult to teach, and I want to get a little bit to. And how do you get the questions? That's right. So just formulating the questions for exploratory data analysis is like the hardest part of it in some sense. So for this, we could have the students study the unit on how do you classify the different types of questions that are appropriate for different sorts of information needs within a visualization, and then you would have them posit those in absence of any data set, and that could be an assignment in and of itself. And I could see that being a whole unit, and then that would feed into this as an exercise. But you wouldn't just throw them out willy-nilly. It would have to be a kind of carefully crafted kind of a thing. Yeah. But there's, people do a lot of great work in the crowdsourcing literature about how do you have people propose things, then have others kind of give feedback on them and self-reflect and so on. Yeah.
I had just a comment about, you mentioned insight, the most important thing, from a visualization is insight to action, right? How do you differentiate the signal from the noise? especially in this age of big data, there's just a lot of data being collected, and really understanding what are those key data points that make sense, that lead to insight that will result in meaningful action. So I was wondering if you had touched upon that in your research.
Yeah, so how do you get insight out of big data? So this is a very early exercise in the course. I have this whole sequence, and this is meant to be for the foundations, like learning to sketch in a art class and so on. So I don't know how to bring that to this sort of pure assessment kind of a level. We are looking at, in our exploratory data analysis unit, we are looking at logging what students do with their consent, of course, and having them self-reflect on the process they went through of formulating hypotheses, exploring those hypotheses to see if the data confirms or refutes it, and then making a display for presentation of the results, and seeing where do they get lost, where do they get confused, what's the process they go through. But that's a much more challenging problem, and in fact, since I am getting a little low on time, I think I will skip the other topic that I've talked about in the past, and kind of jump to that later part, which I can do here. I'm going to skip a lot of stuff here, and go to that topic here. So I'm interested in this idea I'm calling MOOCs in progress, which is that there are some things that we don't know how to teach, we don't really know how to do very well, and exploratory data analysis, or really getting insight from data, is one of those things. And so I talked about this thing. So so I haven't made a MOOC yet, because I guess I just don't feel like I have a course I can just put online and have all the auto grading and everything yet, and I don't know, I'm chicken. I'm trying to slowly develop assignments like this. One reason I'm doing this is I want to put it online. I want to be able to put assignments online that can have the feedback and do it right. And so one thing I teach is this exploratory data analysis unit, and I don't know how to put that online at scale. And I don't really know how to teach it, and I don't even know how to do it that well. Most of us learn from others, and most people that are good at it learn from others and get a lot of practice and see a lot of examples and so on. So I have this idea of a MOOC in progress, which is the people who have put courses out often have been teaching it for years and really gotten it in great shape. And but rather than having to have a perfect course out there where everyone expects it to be perfect, maybe starting with a piece of a course and engaging some experts or semi-experts, people who kind of are already familiar with the topic, and say, hey everybody, why don't you help me develop this course, and bear with me, let's all do it together, we all agree all this subject matter is going to be public domain, and we're going to build it together. So it's kind of like learner sourcing, but they're not really beginner learners, they're kind of people with expertise. And we'll start out with some key material, a core of it, and we're going to refine it together and build it iteratively and explicitly, so that we might have some assignments, and the student will do some work, and we'll revise the assignments, and we'll study the changes in the work, and we'll develop more of a model of how it works, and develop the recommender or the auto-grader. And this can be for exploratory data analysis, or debuggers, or essay tutors, or any of these things where we don't know either how it works at all, or we don't know how to automate it that well. And slowly grow the class out, and slowly add more people that are maybe less expert, until we have a course in a kind of more forgiving way for the instructor. And so I think then what we could do is with these logs, we could ask people, okay, do some exploratory data analysis, do it within these rules that we're giving you, give us feedback on how we can improve this assignment, give us your logs, let us analyze it, and we'll together make this really great exploratory data analysis unit that we can all, that we can then release to kind of any taker. So in kind of a safe environment for the instructor, which is not something we talk about that often. But so that's kind of what I'm thinking, is that's how we maybe could develop these things for these more difficult topics, where it doesn't have to be perfect for anybody who might come along. And then we might be able to get to these harder topics. So given that I don't have that much time. So my concluding thoughts is, at least for me, this learning at scale inspires the imagination. I was just so inspired by the first MOOC that I heard about. I know it wasn't the first one, but Peter Norvig and Sebastian's. And I had a screenshot, but I didn't show it, of Peter's little hand-drawn multiple choice question with the NLP, syntax tree that you needed to fill out. I was really inspired when I started to take one and I saw the active learning where there was multiple choice question after 10 minutes. I'm like, why am I not doing that in my classes? And I proceeded to do it. I proceeded to do active learning and structured peer learning in my courses. I realized I should be teaching this way. No, I wasn't taught this way, but I should be. I learned from a MOOC how I should teach in my classroom. And it inspired me to experiment with things like this, using crowd workers to assess my students' work, which I felt was for me anyway, it was an innovative way to teach. And so it's also made me start thinking, and I actually got some ideas from my colleagues in computer science at Berkeley about this teaching as coaching idea, because they've given up, and some of them, on trying to grade the assignments, which it's out there how to do the assignments, rather letting people repeat them. And then the exams are what count to the grade. And I thought, that's a really good idea. What if we just let people try again, and I can give them feedback and give them points, and it's about the points and about doing it and not so much about the grade, and I'm coaching them. And that has really changed everything. And it's resulted in teaching awards for me. I mean, it's really makes teaching a lot more fun. And I think it makes learning a lot more fun for the students. And by thinking that way, it's changed what I have the students actually do to prep. They prep for every class. They do an activity before the class, and they do activities in the class. And the activity, I vary them a lot. I've read a lot of the pedagogy, so it's not they always do this or that. They do a different thing before different classes. So, and again, these are enabled because I can do stuff online. So I really do think we are revolutionizing learning, this plus what's going on with the learning at scale community. And I hope that a lot of you are inspired to go into this field. I know that for students, education is very exciting, and I heard that a lot of you are thinking about it, and I'm really excited to see that a lot of the best minds are thinking about education going forward. So thanks so much for your attention.
Much faster in other cases.
Yeah, there is, as Manish was saying, there's a lot of variation based on which subset of data is shown in the visualization, which subset of data is asked about, and what combination is asked for in that combination of the question and the data. But of course, when we assess things now, are we looking at those? I don't think so. So I would argue it's better than what we currently do, whatever that is. Yeah. Stu.
I thought one of the most interesting things in your analysis, the one where you did the correlation between the two and focused on the outliers, is that what you want, at least in some techniques for asking questions you didn't think to ask. So what this outlier does, and it looked like the outlier would probably determine your whole result. And this is both the problem that the question that the outlier implies, which could be a whole domain of things you would have to ask about, and the way of measuring the results. So I thought that was nice, the way to combine the scale, a couple scales, in a way that popped out these outliers that you didn't know to ask about.
So your suggestion would be maybe to use that to decide what the additional questions should be, for example?
We stumbled into a version of that in eye tracking, where we have a theory of how the interface ought to work, and we try to measure that. But every once in a while, we discover one of these things pops out. That even if the design was basically okay, there's some huge piece that got put in there that's causing a problem.
That's really cool. So one thing that happened when I first did this exercise is the student did a design that was really different than anything I had seen or I would have thought it was terrible. It was kind of like this red and green stoplight table sort of thing. And I thought it was awful. And it came out the top in scores. And I was so glad I had done it this way, because I would have led them wrong. And maybe I'm just a bad judge and I need to see more things. But it was one reason I was so glad I had this objective approach. And I think I've seen more things like this, and I think I've learned the pattern, that it's a good design pattern. And I tested it here, and actually it did well in the heuristics too, so maybe the students are smarter than I am. But you could imagine things going the other way. So like you're saying, it's for me that table, that scatter plot is the key thing. I think you were probably making a more sophisticated point though about this suggests we need to ask more questions. Or maybe you're saying that's saying the outlier.
Allows you, especially in the early part, to become aware of things that you didn't think to ask for. So scatter graphs are the thing that Tukey like. And I can't think of the name of it right now, but that technique where you have people give lists of things that went wrong and generalizations of the world.
I'd love to hear more of your thoughts about that.
Yeah. We should talk about it.
All right, let's thank Marty one more time.